Good afternoon, everybody. I hope you all are doing well. My name is Jeff Shaman. I'm the Senior Vice Dean here at the Columbia Climate School. Welcome to our first Signature Speaker Series event of Spring 2025. We're very excited to have our guest of honor here, whom will be introduced in just a moment. I hope everybody is doing well. We have a sunny day. It's getting a little bit warmer. The Hudson has thawed a bit, and we'll have to see what kind of temperatures the summer brings to us. We will talk a little bit more about a number of things that are of importance for climate, and I'm going to turn it over now to Marco Tedesco. Dr. Tedesco is going to introduce our speaker. Please.
Thank you, everybody. Thanks for coming. Thanks, Elizabeth, for being here. Thanks for coming to Lamont this morning. The reason why Elizabeth is here is because we spent some time in Greenland this past summer, and we got to know each other better. And she clearly still doesn't dislike me as much. And she agreed to come to Columbia to give these talks. One thing that struck me in this field work, and she doesn't know, is that when I asked her what you're looking for, her answer was like, I'm interested in what my readers are interested in. And as a scientist, I think asking myself, what are the reasons why we keep doing climate science? This answer resonated very strongly because I keep thinking about why do I study Greenland melting, what does it matter, and what are the implications for society, especially for socially vulnerable people. So thank you, Elizabeth, for another great answer and teaching me. Elizabeth is an American journalist and author. She won the Pulitzer Prize for The Sixth Extinction, and she's a staff writer for The New Yorker. The Sixth Extinction was also a New York Times bestseller and won the Los Angeles Times book for the science and technology. Her book, Under a White Sky, was one of the Washington Post 10 best books of 2021, and she is a two-time National Magazine Award winner, and in 2022, she was awarded the BBVA Biophilia Award for Environmental Communication. Elizabeth Kolbert, thank you so much.
Hi, everyone. Thanks for coming out this afternoon on a beautiful afternoon. I am going to begin. Hold on one second. We were supposed to have. Oh, sorry. Okay, so I'm going to begin at my talk this afternoon at another university, which is a couple of thousand miles away from here. Can everybody hear me? Yes, okay, good. So this is the University of Wyoming Engineering Hall in Laramie, Wyoming. And the building was constructed in the 1920s with the proceeds from oil that was found right on campus. And when you are there, if you look up to the top of the building, about 50 feet above the ground, you see this message carved into the stone, and it says, "Strive on, the control of nature is won, not given." I don't know where this exhortation comes from or who thought it up or who thought to put it on the building, but I will venture that at the time the building opened, most people who walked through the doors found it inspirational. As I said, this was sometime in the 1920s. I'm not sure exactly what year. And there was a great deal of faith in the future that humanity was creating for itself, in the idea that nature could and should be harnessed for human ends. This was at the very heart of what it meant to be an engineer. So to give you one example of what was going on at the time, this is a schematic drawing of something called the wood screw pump, which was patented in the year 1920. And the wood screw pump was not actually made out of wood. It was invented by a man named A. Baldwin Wood. And it was this huge pump that allowed them to basically drain the swampy marshlands around New Orleans and create these whole new neighborhoods. Any of you who are actually from New Orleans or have been to New Orleans, vast neighborhoods were created by draining this land. And the New Orleans Item, a paper that no longer exists, ran a piece celebrating this achievement, and I quote from that, "Man is every day surpassing nature." So in the century since then, the century since the engineering building was erected and the wood screw pump was patented, the phrase, the control of nature, has taken on a lot more baggage. It has an interesting place in the history of journalism, in the history of environmental journalism. In the late 1950s, Rachel Carson started working on the book that would eventually be published as Silent Spring. And the title, Silent Spring, it comes from a John Keats poem, La Belle Dame sans Merci, which I hope you have all read, a wonderful poem. And that title, Silent Spring, was actually suggested by Rachel Carson's editor. No, sorry, her agent. But while she was working on it, she had a working title for the book, and it was called The Control of Nature. And this was not in Rachel Carson's hands, or mind, I guess. This was not the triumphalist sense that the engineers at the University of Wyoming had intended. This was the control of nature in a new and much darker key. So since, in the 30, 40 years since the engineering hall in Laramie had been completed, not only had much of the country been visibly transformed by people, it had also been invisibly transformed. Radioactive fallout, while impossible to see, was showing up everywhere, including in toddlers' teeth. And synthetic pesticides, too, were ubiquitous. Designed to kill insect pests, they also killed fish and beneficial insects and birds, and, as Rachel Carson pointed out, on occasion humans. And though the phrase, the control of nature, was dropped as Carson's title, she makes very pointed use of it in the closing pages of Silent Spring. So this is a quote from the end of the book. The control of nature is a phrase conceived in arrogance, born of the Neanderthal age of biology and philosophy, when it was supposed that nature exists for the convenience of man. So a couple of decades after Silent Spring, another journalist, another environmental writer, John McPhee, paid a visit to the University of Wyoming. And as he stood outside the engineering hall, he was struck by the inscription over the entrance, and he ended up borrowing the phrase for the control of nature for the title of a wonderful book he published in 1989. And if you haven't read McPhee's Control of Nature, I really, really recommend it. So McPhee, like Carson, had major doubts about the whole control of nature project. But whereas Rachel Carson's tone was worried and anguished, McPhee was skeptical, even bemused, you might say. And at the center of McPhee's Control of Nature is a story about a volcanic eruption on the island of Heimaey off the southern coast of Iceland. The eruption took place in 1973, and it destroyed a lot of the infrastructure of the island, that one main town on the island. And in an effort to save the other half and to save the port that the island used, the Icelanders began quite literally to hose down the volcano. This is a sort of very famous, example of trying to control nature. So between February 6th and July 10th, 1973, they pumped approximately 8 million cubic yards of water on the lava. And the Icelanders convinced themselves that this had made all the difference. This had stopped the lava from destroying the rest of the town. But as McPhee notes, the truth of all this, and I quote once again from The Control of Nature, will never be known, the role of luck being unaccessible, the efforts of intervention being ultimately incalculable, and the assertion that people can stop a volcano being hubris enough to provoke a new eruption. And as an aside, as you probably all know, Iceland is now dealing with a series of eruptions that are really very disruptive, not too far from Reykjavik, and they are once again trying to stop the lava. This time, though, they're using these huge earthworks, barriers, and I think they've actually been somewhat successful, semi-successful. So anyway, why am I beginning here? Ultimately, today, I want to talk about geoengineering, about its appeals, and about its hazards. Geoengineering is the topic of the last chapter in a book I published a couple years ago, and it provided the book's title, Under a White Sky. If I could have, if McPhee hadn't already used it, I would have called the book The Control of Nature. So since McPhee published The Control of Nature, I would argue, we've entered a new phase in our understanding of nature, and no less significantly of control. Today, the issue is not so much the human effort to control nature, either arrogantly, per Carson, or delusionally, per McPhee. The key thing is that without even seeking to, we do control nature, or at least we dominate it. I keep a running list of the statistics here that I find relevant and fascinating. They are on one level very impressive, and on another level totally terrifying. I'm sure everyone in the room today is familiar with some of these, maybe even most of them, but there may be some that surprise you. So here's just a sampling. Humans have directly transformed more than half of the ice-free land on Earth. This amounts to about 27 million square miles. We've done this in all the obvious ways, by building cities and suburbs and reservoirs, and also by cutting down forests and planting monocultures. And we've probably transformed roughly half of the rest indirectly by doing things like laying seismic lines and logging roads and natural gas pipes, oil pipelines. Humans have dammed or diverted most of the world's major rivers. Okay, there are about 250 rivers on the planet that are 1,000 kilometers long or longer. And a study published in Nature a few years ago found that only a quarter of those now flow uninterrupted to this ocean, and that, quote, very long, free-flowing rivers are restricted to remote regions of the Arctic and of the Amazon and Congo basins. That same study found that there are nearly 3 million dams in the world, and another 3,700 hydropower dams were, at that time, either planned or under construction. We now routinely cause earthquakes. This is mostly owing to fracking, but also in some cases, earthquakes have been caused by drilling for geothermal. In terms of biomass, the numbers are really stunning. So these figures are from a paper that appeared a few years ago in PNAS. You can see that humans now outweigh all wild mammals, all of them, by a factor of 9 to 1. And if you add in our mammalian livestock, which is mostly cows and pigs who weigh a lot, that ratio climbs to 24 to 1. So humans, we, and our livestock outweigh wild mammals by a ratio of roughly 24 to 1. Here's another way to look at things, and another extraordinary figure. This is from a paper that came out a few years ago in Nature, and what this is showing you is that the weight of human-made stuff, what's here called anthropogenic mass, the weight of all human-made stuff on Earth is now roughly equal to the weight of all biomass on Earth. So that's all the plants, all the animals, all the fish, all the plankton, and so on. And the weight of human-made stuff is presumably increasing, going to keep increasing every year, and the weight of biomass is presumably going to stay flat or decline, and so those lines are soon going to cross, perhaps already have crossed. And human-made stuff is going to outweigh the biomass. And here's another paper from that same another figure from that same paper that's really quite stunning, so that animal biomass on the planet totals about 4 gigatons, and that includes fish and mammals and insects, and the mass of plastics on Earth is twice that amount, 8 gigatons. I'm quoting from this paper, this Nature paper, the accumulation of anthropogenic mass has now reached 30 gigatons per year. The authors of the paper note, this corresponds to each person on the globe producing more than his or her body weight in anthropogenic mass every week. And then, of course, there's climate change, no surprise for anyone at the Columbia Climate School. I'm just going to cite 2 very recent figures. Here we have the latest readings from the Keeling curve, up over 425 parts per million. And this past year, so basically 2024, CO2 levels took a record jump of more than 3.5 parts per million. So 20 years ago, the Nobel Prize-winning chemist Paul Crutzen, he won a Nobel Prize. He was part of the team that won for discovering the effect of ozone-depleting chemicals. suggested that we are now living in a new geological epoch, the Anthropocene, defined by the scale of human impacts. And there is, as I'm sure you know, a very active debate about the Anthropocene, a debate about that encompasses both science and politics, a debate about whether this is the right term, a debate about whether we really live in a new geological epoch. But I bring it up just to say that when Crutzen proposed it, he suggested that we use rising CO2 levels, where we start to see CO2 levels start to rise at the start of the Industrial Revolution around the year 1800, which you can see recorded very clearly in Greenland ice sheets, that we use that as the official mark of the start of the Anthropocene. We use that as the so-called golden spike. Now, my own reaction to all this, and I'm guessing for many of you, most of you in the climate school, is your reaction as well, is these are not good trend lines. I don't want to keep harping on plastics, but they are very much in the news these days, and if current trends continued, then by 2050, it has been predicted that there will be, by weight, more plastic waste in the oceans than fish. And this just does not seem sustainable. And a logical response is, well, let's change the trend lines. This is a response that many people in this room, many people I respect and admire, of course, advocate. They say we need to scale back. Let's stop converting forests into farmland, into monocultures. Let's stop burning fossil fuels, or at least burn a lot less fossil fuels. Let's stop producing plastics, or make a lot less plastic. And there's a very compelling case, obviously, to be made for this response, a very strong case on environmental grounds, and perhaps an even stronger case on ethical grounds. But as you all in this room know, that is not what we are doing. I don't see a lot of evidence that we are scaling back, about to scale back, or to put things even more starkly, I don't see a lot of evidence that we have any appetite for scaling back. Right now, you could certainly say on the contrary. So while walking things back is not just a good idea, but probably a necessary idea, it does not appear to be our current trajectory. And this is the other reason to invoke the message on Engineering Hall in Laramie. The message may seem quaint in its optimism, but it's still very much, if we're honest about it, the message that we're living by. Only now what we're striving to control is not a nature that exists or is imagined to exist apart from the human. Instead, the new effort begins with a planet remade and spirals back on itself. What we are attempting to control is a nature that we ourselves have helped bring into being. So Under a White Sky was my attempt to help people who are not experts in the way you guys are, to see this pattern and think through its implications. And the method of the book is the method of a journalist. It's not constructed as an argument, it's constructed as a series of stories. And I thought I would just tell two of these sort of control of nature stories or control of nature parables before I get to geoengineering, which is the last story in the book. And the first story begins in Chicago, on the Chicago River. This is what the Chicago River looks like on March 17th every year. I'm sure it's what it will look like in a couple weeks again, because every year on St. Patrick's Day, the river is dyed green, which some people think is pretty, and I think is pretty telling. So the city of Chicago grew up on the Chicago River, which, as you can see, runs right through the center of the city. This is a map of what the Chicago River used to look like when the first sort of white settlers began settling the area. It had two branches which came together and then flowed east into Lake Michigan. And as the city expanded, the river was absolutely key. That's why Chicago is where it is. It essentially served as the city's sewer system. So all of Chicago's human waste and also all of the animal waste from its stockyards, as you all know, Chicago, city of broad shoulders, huge stockyards, it was basically dumped into the Chicago River. And it was said that the Chicago River was so thick with filth that a chicken could walk across it without getting her feet wet. And there's part of the river today that's known as Bubbly Creek that's still, where methane is still coming off the ground from those carcasses that were dumped, a century ago. There's just so much organic matter decaying at the bottom of the river. So as the city grew, this became a huge problem because Chicago gets its drinking water from Lake Michigan. It still gets its drinking water from Lake Michigan. So there were a lot of outbreaks of waterborne disease, and it was decided that something would have to be done. And what they decided to do was reverse the flow of the Chicago River. This was a massive construction project, perhaps the biggest of its day, and it created what's known as the Sanitary and Ship Canal. And when the canal was completed, instead of flowing east into Lake Michigan, the Chicago flowed west, or really southwest, into the Des Plaines River and on into the Illinois River and the Mississippi. And in 1900, this was completed in 1900, the New York Times ran this wonderfully snarky headline, "Water in the Chicago River now resembles liquid." So these maps give you a sense of the before and after, okay? What the river system looked like before the canal was dug and then after. So reversing the Chicago River solved one problem, but in the process created a new one. So before the canal was dug, we had two independent drainage systems. We had the Great Lakes drainage system and the Mississippi River drainage system. And these two basins were distinct. There wasn't a lot separating them, and it's very flat in that area, but they were distinct. And you couldn't, if you were an aquatic species, you couldn't move between them, or it was very difficult to move between them. And now, when they opened up this canal, anything could swim or shimmy or wade from one system to the other. And as the 20th century wore on, both of these systems became highly invaded. Part of that was also due to the construction of the St. Lawrence Seaway. And this shows you the latest tally of invasive species from the Great Lakes. The Great Lakes are an extraordinarily heavily invaded ecosystem. And you see that we're up to 184, and probably, honestly, this is out of date. Probably there are a couple more by now. And one of the most ecologically significant invaders, as many of you probably know, are Asian carp. And Asian carp are usually referred to as one fish, sort of grouped together, but they're actually four separate species. And each one was imported to the US purposefully as a form of control. The idea was that each one of these fish would perform some useful function. So grass carp, for instance, eat weeds, and the idea was that they were going to be used to get rid of aquatic weeds without using herbicides. And this sort of biological control gained a lot of currency, ironically, paradoxically, thanks to Rachel Carson and Silent Spring. So in the last chapter of Silent Spring, those of you who have read it recently remember she really pushes biocontrol as an alternative to chemicals. Excuse me. But that distinction, as we now realize, is kind of a mistaken one. Biological control is still control, and it can still go very badly awry. And as you have probably guessed, these imported carp very quickly got out of control. They escaped from where they were often in experimental ponds, and they have basically taken over the Mississippi River system. In some parts of the river system, Asian carp now make up more than 3/4 of the biomass. These are silver carp, which have a very exciting but also very unfortunate tendency to jump when they are startled, and one of the things that startles them are motors. So if you're out boating, it can be a really exciting and very dangerous situation. I myself have been hit by an Asian carp, and it can be very painful. Anyway, so as Asian carp swam toward Chicago and the Great Lakes, now it was decided that something was going to have to be done about this. We were going to have to engineer our way out of this. And so the Army Corps of Engineers was called in to add a new kind of control, one that would be superimposed on the old. And what the Army Corps of Engineers came up with was a series of electric barriers. So if you are going down or up the Chicago Sanitary and Ship Canal, something that very few people do, I'll be frank, but that I had the pleasure of doing, you eventually get to this sign. And it says, don't go into the water because you may get electrocuted. And the core is pulsing a lot of electricity through the water in the hope that these carp, who are quite big, will experience a shock and turn around. But no one is that confident that this is going to work or is working. So another barrier is planned farther south. And this one is going to feature not just electricity, but also noise and water jets, and has been referred to, someone joked to me that it's a disco barrier. The cost of the project keeps going up. It's now up over $1 billion, but the first contracts were recently awarded. So my next story begins at the opposite end of the Mississippi. So now we're at the mouth of the river in New Orleans. The French established New Orleans in 1718, so just 7 years ago, New Orleans celebrated its tricentennial. And they built their settlement right on the banks of the Mississippi River, and pretty much as soon as the first buildings went up, the river flooded, and the settlement had to remain submerged for 6 months. And the response of the French was not to give up and move away, but to take control. And they started to build levees and to keep the water out. And a lot of the actual labor, of building the levees, this was backbreaking labor. A lot of it was done by enslaved people from Africa. By the 1730s, slave-built levees stretched along both banks of the Mississippi for almost 50 miles. And these early levees were built mostly out of earth and timber, and they frequently failed. The river broke through them. And again, the response wasn't to move, it was to build up the levees. So by the War of 1812, the levees along the Mississippi extended for more than 150 miles. But still, they often failed. They developed breaches, which the French called crevasses, and the water came pouring through right into the center of New Orleans. So this is a picture of a particularly famous crevasse that opened up. It was called Sauvé's crevasse. It opened up in 1849. And you see what the city of New Orleans, that's Canal Street, for those of you who know New Orleans, so you could boat down Canal Street. And in what's become known as the Great Flood of 1927, the levees, which by then were much stronger and higher, failed spectacularly. There was flooding up and down the Mississippi, and more than 500,000 people were displaced. And at that point, yet again, people could have finally said this project, isn't working, and given up. But instead, at that point, the federal government took over, the US federal government, and began building even more massive levees. And during Hurricane Katrina, as we all know, those once again failed spectacularly. So since Katrina, since 2005, more than $2 billion has been spent to upgrade the levees and seawalls in New Orleans. So have the levees, which by now have really expanded to be not just levees, but a huge water management system, have they worked? From a certain perspective, yes. They are an extraordinarily impressive engineering accomplishment. This is just one very small part of this water management system. It's really a pharaonic, system. Much of New Orleans, as you probably know, sits below sea level. It's sinking very fast. It's one of the fastest sinking places around. And for the most part, it does stay dry. So in this sort of tactical sense, if you want, in this immediate sense, the system does its job. But seen from another perspective, this effort at controlling the Mississippi starts to look self-defeating. The whole Mississippi Delta was created by the Mississippi. This is a map that shows you how the river created over time that whole part of southern Louisiana. So what would happen was that the river, in springtime, when there's a lot of snow melt, is churning up sediment, and it would bring the sediment down to the mouth of the river, and then as it slowed down, as it hit the Gulf, it would drop this sediment. And then when it had built up a big bulge of land, it was sort of starting to get in its own way. This land was starting to get in the river's way. There would be what's called an avulsion, and the river would seek a new course, and then it would build up another bulge of land. So the Mississippi really assembled the whole Louisiana coast out of bits and pieces it had picked up in Illinois and Iowa and Minnesota and Missouri and Kansas. And it is the nature of deltaic soils to dewater over time, to compact. And as the soil dewaters, it sinks. So before the levee system was perfected, each flood brought new sediment, and that more or less made up for the last year's compaction. But by the perverse logic of this kind of thing, the better people have managed to prevent the river from flooding, the more precarious New Orleans' situation has become. As I mentioned, it's one of the fastest sinking places on Earth now. And as it sinks, of course, that whole levee system sinks with it. So some parts of the city are dropping at the sort of astonishing rate of half a foot per decade. So what to do? Well, one response would be to really, dig deep, as it were, and rethink our efforts to control the Mississippi. It would be to say, that the path that we've pursued for these 300 years is kind of a dead end. And that would mean that New Orleans would have to be fundamentally reimagined. But for all sorts of reasons, both political and economic, and you could argue humanitarian, really fundamental change is not considered an option. It seems to us at this point too late. New Orleans is just too big, it's too important. More than 350,000 people live in New Orleans. It's a great American city and an important port. Although I should mention as an aside that New Orleans is shrinking, its population is shrinking. So the solution, as it were, such as it is as envisioned, as imagined, is not to back away from the project of control. Instead, it is, once again, to try to layer another layer of control on top of the first, second-order control, if you will. And here the idea is to create what are called sediment diversions. So these are sort of a new kind of massive engineering project. And basically, the idea is to create a fake crevasse that can be managed. So the idea is that there will be gates built into the levees south of New Orleans, and when the river is running high, once again, presumably mostly in the spring, and when it's carrying a lot of sediment, it carries a lot less sediment than it used to because we've also, levied up the Missouri River and these rivers that are leading into the Mississippi that used to dump a lot of sediment into the Mississippi, but there's still a great deal of sediment in there, the big, muddy. So when there is a lot of sediment in the water and when the river's running high, they will open these gates, and it is hoped that that sediment will then be deposited in these shallow bays south of New Orleans, like Barataria Bay. And the first of the structures that's supposed to be built is called the Mid-Barataria Sediment Diversion. It's supposed to be 600 feet wide and 2.5 miles long. And this is a mock-up of what it would look like. And when it's operating at maximum capacity, 75,000 cubic feet of water will pass through it every second, which will make it, in terms of flow, the 12th largest river in America. And this, when you think about it, of course, this will not prevent New Orleans from continuing to sink because it's really just impossible to get sediment into the city without flooding people out. But the hope is that some of the wetlands south of the city, which have really been starved for sediment, will start to rise then above the water level. You'll be sort of growing the land south of the city, and that this will buffer the city from storms that are coming off the Gulf of Mexico. So this project is expected to cost $3 billion, and it was set to begin construction last year, but it has been held up in lawsuits. So this is a headline that I saw just the other day, and I don't think we exactly know what the fate of this project is. It's very much disputed, actually by fishermen who don't want to change the salinity of the bay by dumping a lot of fresh water in there. So this brings me to my last story, or really stories, which are about climate change and how we can see this pattern, once again, working itself out. So this is a project I visited a few years ago in Iceland. I managed to get there at the height of COVID, which was a story in and of itself. And what you're seeing here, would look like sort of big air conditioners. These are direct air capture units. I'm sure you all know here about in the climate school about direct air capture. It's possible some of you are even studying it. The Iceland project belongs to Climeworks, which is based in Zurich. So inside those units are chemicals that absorb CO2. The precise formula, I can't tell you, that's proprietary. Once the chemicals are saturated with CO2, heat is applied, and the CO2 gets forced off and pumped away. And then the process, then it cycles. So then you bring in more air, and you allow it to react and with more CO2, and you, once again, it gets saturated, once again, it gets heated over and over again. And once enough CO2 has been collected, they collect it in these huge bladders. It gets piped. In this particular version of direct air capture, it gets piped very deep underground, a mile deep, into this Iceland's volcanic. All of Iceland is just basically one big lava field, into this volcanic rock. And very deep underground, the CO2 reacts with the rock and also a lot of water, and it forms calcium carbonate, so basically chalk. So you're basically converting atmospheric CO2 into chalk. And if you could peer underground, this was a core that was taken up to, proof of concept that we really are creating this calcium carbonate. This is what it looks like. They pulled up this core. So you can see that vein of white there. That's a vein of calcium carbonate that was formed by this CO2 injection. So this is one version of what people mean when they talk about negative emissions. There are all sorts of alternative technologies. I know people at Lamont are looking at ways to produce negative emissions, for example, through ground-up rock. And as I'm sure you know, there are lots of negative emissions built into most integrated assessment models used by the IPCC. That blue wedge there, that is what it would take to keep temperatures from rising more than 1.5 degrees C, which we all know isn't going to happen. This is according to the IPCC, once again. But there's a lot of negative emissions even built into 2-degree scenarios as well. So all that blue is what you need to take out of the air, many billions of tons. And that was the case. We needed all those negative emissions for these scenarios, even before Donald Trump decided to do everything he possibly could to promote the use of fossil fuels. Will progress be made? Are these useful technologies? In both cases, I'm sure the answer is yes. But there is a catch, of course, and the catch is scale. To remove CO2 on the scale that's necessary to alter our trajectory, to make up that blue triangle, requires an infrastructure on the scale of our fossil fuel industry, which of course is ginormous and has been built up over a century now. And then finally, we get to our ultimate fix, geoengineering, or it is sometimes more soothingly referred to solar radiation management. So this is a drawing of solar geoengineering, what it might look like, how it might proceed. I'm sure most of you are familiar with this. Some of you, once again, may be studying it. The idea is we would build some aircraft that could fly into the stratosphere, carrying a very heavy payload, and these aircraft would spray some kind of reflective particle up there. It would be some sort of very fine particles that would drift around and create this stratospheric haze, which would reflect sunlight back to space, so actually less direct sunlight would be hitting the Earth. And this would, for obvious reasons, have a cooling effect. And the reason that we think this could work is because it is pretty much what volcanoes do. They emit large amounts of sulfur dioxide, which then condense into these little droplets, these sulfate droplets that are very reflective. And that's why after a major eruption, that's Mount Pinatubo going off in 1991, you get these fantastic sunsets, and you also get temporary global cooling. So that cooling lasts until these particles fall out of the stratosphere, which takes a year or two. But if you could stage these constant fake eruptions, the idea is if you sent this fleet of aircraft up there, you could constantly replenish the particles and therefore maintain that cooling effect. And I hope that the parallel now with the Chicago River and New Orleans and carbon dioxide removal is clear. Once again, one form of intervention begets another. Having screwed up the troposphere, we go about imagining ways to mess with the stratosphere. Solar geoengineering has been described as dangerous beyond belief, as a broad highway to hell, and as unimaginably drastic. The possible side effects are manifold. They include changes in regional weather patterns, damage to the ozone layer, and changes to the color of the sky, hence the title of my book. The first experiments related to solar geoengineering were supposed to take place a few summers ago in northern Sweden by this group in Harvard that you may have heard about. They were supposed to use scientific balloons, like this beautiful balloon there. They were very tiny, small-scale experiments that would not have had any climatic impact. But they ended up being canceled because there was so much opposition to them in Sweden. And I myself sympathize with this opposition, but such opposition does not, of course, address the underlying problem, which is that we have altered the atmosphere and hence the climate. So the question here is the world better off with the climate we are right now engineering by burning billions of tons of fossil fuels or emitting billions of tons of CO2, or is it better off with a climate that's been altered in one direction owing to the CO2 that we've put up there and then altered in the opposite direction by putting reflective particles in the stratosphere? And questions like these are, at various scales, going to keep presenting themselves. There are plans to build a huge series of gates and dikes across Galveston Bay to protect the city of Galveston, the so-called Ike Dike. And now none of this has been built yet, but it has a price tag already estimated at $30 billion. There's a proposal to build an equally elaborate series of gates and seawalls to protect New York. There's a lot of opposition. If you want to look at the Army Corps of Engineers proposal on that, it's online. There's a lot of opposition to both these projects. They have, obviously huge costs, huge environmental ramifications. I don't know if either will get built, and I don't know if either one of them should get built. But once again, these massive engineering projects have to be assessed against the alternative. Sea level are rising, and the rate of rise is accelerating. So in low-lying coastal cities, like the one we are in right now, doing nothing is likely to mean that whole neighborhoods will have to be abandoned. And that is obviously also an unattractive alternative. So as engineers, humans were already capable in 1900 of reversing rivers. We've now sent probes to Saturn and mapped the human genome. Our talents have been extended in directions that earlier generations of scientists and engineers could hardly have imagined when the engineering hall in Laramie was erected with its directive, strive on, carved in the stone. With great power comes great responsibility, as Spider-Man tells us. But so far, we have not exercised much in the way of responsibility. We've acted as if there are no limits and as if new technologies will always come along to our rescue. And I'm going to just end by saying I wish that I had more confidence that they actually will. Thank you very much. And I'm happy to, thank you. Yeah, if there are questions, I guess there's a mic down here.
Elizabeth, thanks for your talk. Alex DeSherman and I run a center here at the Climate School. You mentioned in each of your cases you showed lots of unintended consequences from choosing that particular solution. Sometimes they might have been known, but they weren't necessarily, the cost benefit wasn't fully calculated, or maybe it was oversold. In the area of solar engineering, what are the biggest concerns about what might happen apart from, sunsets turning red and the sky no longer appearing as blue as it is today? What are the biggest consequences that people are talking about? Thanks.
Well, there's a list Alan Robach, I think he's at Rutgers. I'm not sure, he might have retired since I read the book, but he maintains a list of concerns about solar geoengineering, which you can look up. They're very extensive and varied, and even the people who are, studying / advocating geoengineering, they're often very careful to say they're just studying it, they're not advocating it. But anyway, they would say that, if you actually were trying to cancel out the CO2, this, warming that we've put in the pipeline into the system, there would be huge ramifications. So no one's even really advocating that at this point. But even if you were just to try to sort of minimize, cut what they call cutting the top off the curve of climate change, the risks are to regional weather patterns. How are you changing regional weather? How are you affecting the monsoons after big eruptions? You tend to get monsoon failures, for example. So I am no expert on but lots and lots of people are trying to model what it would do to different regions of the globe. And then there are also, of course, the geopolitical ramifications of who's doing this. Is it everyone's agreed to do geoengineering? Has some countries agreed to do it? And who compensates those countries if there are winners and losers? So it's a huge geopolitical problem, and also I think that the effects on agriculture, you have less direct sunlight hitting the earth, and some people say, well, that's okay. Plants don't really want direct sunlight. They like indirect sunlight. But there are all sorts of, as I say, regional patterns. Your effects on your solar power industry, there are measurable effects on solar generation. So, but I think the big one that people would point to is changing weather patterns.
Thanks for a great talk, Elizabeth. I'm Jatan. I'm a researcher at the Climate School. I understand some of the science here, but what I don't understand is politics. So my question to you would be about that, especially in the atmospheric intervention. So I really like the framing that you use about the troposphere versus the stratosphere. But I think on the political end, I think of this as like, if the actors are diffuse, then that somehow gets a pass, versus if the actors are concentrated in some organization or a group, it doesn't. So the illustrative example for this in my mind, and it's a topic that is of current interest in the climate community, is the temperature spike in 2023. And does, say, the reduction of sulfur in shipping fuels have a contribution? And that to me is like a diffuse action. The IMO, basically had a policy, and we are sort of seeing the effect of that. Maybe it is that, maybe it's not that. I mean, the science is still not clear. But I'm just wondering if you could comment or just share your thoughts on how you see this going forward politically, and this sort of bias, the different biases between diffuse actors and concentrated actors.
Yeah, well, I would just also, I mean, it's a really interesting sort of question. It's also a question of, I think another really fundamental question, right, is between unintentional climate engineering, right, which is what we're doing. We're not burning fossil fuels to alter the climate. They just happen to be altering the climate, and intentional engineering. And are there different thresholds for these unintended consequences versus intended consequences? And I think one of the big challenges faced, and there have been some pretty well-funded efforts to look at governance of geoengineering, and I don't think they have reached any particularly novel conclusions. But if you have a world that can't agree on the basics of well, we really need to cut our fossil fuel use, and here's how we're going to go about it, then how are you going to get that world to sort of agree on geoengineering? And another point that people would make, once again, this ramifies in many, as you know, many different directions. Where are you committing? You're committing future generations, right? I mean, this is not like a short-term project, because CO2 is such a long-lived gas. So are you going to say, okay, we're going to be doing this forever now? What are you actually saying? And these are questions that are, way above my pay grade. I don't claim to have answers to them. I don't think anyone has answers to them. But I guess the one thing I would say is, the longer we delay, the more CO2 we put up there, the more, this idea of having, some engineering solution in our back pocket, the more we're going to be compelled to think about that. And it also has, I think it's going to get, this is just speculation, but sort of more and more, sort of high tech. It's a techie solution. It's going to have more and more techie people behind it, for better or for worse. How's that? I'll just leave it at that.
Hi, Elizabeth. It's Paul. I'm wondering, you finished I'm over here, other side.
Sorry.
You finished the talk on a slightly pessimistic note, and in class we read your book, Hope, also ends on a slightly pessimistic note. I'm wondering, what keeps you going? Why are you still writing about this? Have you given up hope? Do you still have hope? What's the situation?
Yeah. Well, there's a great line from Jim Hansen when he was asked about hope. I once heard him say, "I hope you're listening." I think that, I think if you're not pessimistic right now, you're, delusional. How's that? But that being said, I think there's, we're talking about degrees of damage. That's what we're talking about right now. And there is, of course, still a lot to be done to minimize the damage. We're not doing it. We seem to be racing in the wrong direction at this particular moment. But I think, what keeps me going as a journalist, I really do want to emphasize, that's what I do, is it's fascinating. It's really fascinating. Even what's happening, if I could divorce myself as a person, from a citizen of this country from what was happening, I guess I would also say it's fascinating what's happening. It's also, terrifying. But it's really interesting. Planet Earth is really interesting, and what we're doing is really interesting. But it's hard to be. I've been at this a while now. I've been writing about climate change for 2 decades, and every time we seem to be making even a slight bit of progress, we then backslide really seriously. So it's pretty hard to, I'd say at this moment in time particularly, pretty hard to find those glimmers of hope. But there still are some out there, and I urge people to cling to those.
Over here on your left. So in the last few years, I haven't read your book, but after the shout out to John McPhee, I'm going to go pick it up. But in the last few years, it seems like there's been a real shift in the mainstream or public media about geoengineering. It's getting more coverage. I'm thinking particularly of the series in the New York Times. And the way it's framed, I feel like it's normalizing it as an option. I'm just wondering if you have had a sense of a shift.
I don't know. I don't think that. I think that what you see is that, to a certain extent, climate change is now this old story. It's the same story. It's like climate change is here, climate change is here, climate change is here. It's worse, it's worse, it's worse. And these crazy ideas. The Times did this piece on buttressing ice shelves and that form of geoengineering, which is really out there, and I don't think anyone thinks is terribly plausible. But that's a new idea. That's a new idea, and so it gets some attention because it seems new and different. Not that there's any conscious decision by anyone, including the journalist who wrote it, that this is somehow going to happen. It just is sort of a novelty. So I think that these things keep getting coverage because they're novelties, to be honest. And that's true of a lot of things, even in the climate tech space, right? Someone announces, oh, we've just found a new way to do X or Y, and when you look beneath the hood, you're a lot less, convinced of it, or we just found a new, we're going to do fusion now, we're going to do this now, and those get coverage because people are looking for a different story as opposed to, it's another record hot year. I believe that's sort of what's going on. Does that have the effect of normalizing it? Potentially, but journalists don't worry about that kind of thing, as you know.
Hi. I'm an environmental engineering student, and you've kind of spelled out this recurring problem of we try to change the environment to better suit our needs. It has all these unintended side effects. We try to fix those unintended side effects. It has more unintended side effects. What do you recommend that people like me should change about the methodology of how we approach problem solving? Because it's obviously easy to say, oh, we should think harder about the impacts of our actions in the future, but what do we actually do in the future to stop this recurring pattern from just keep happening over and over and over again?
Well, I'm going to turn the question back on you because, as I say, I'm just chronicling this. I'm not solving it, and I think I got that response honestly, to the book. Well, what are we supposed to do? And my answer is I don't know. I don't know what we're supposed to do. Obviously one thing would be to do the big rethink. And people, I will say, let's take the case of New Orleans. After Katrina, there was one brief moment where people were like, okay, let's radically reimagine New Orleans. And there was a big exhibit, and a bunch of engineering firms did do radical rethinks of New Orleans. And then all of those plans, got dropped in the garbage. Nothing happened like that. So, one thing that people could do, but I realize this is not, it doesn't pay the bills, it doesn't really tend to make it through the political process, is say, okay, do we need to, just start from scratch here and say everything is on the table? And I guess my only, that's the only thing that I can think of. I mean, I will say that I think that, I do think that people are in all of these different directions that we're going in, and from genetic engineering to, engineering and geoengineering, trying to think through the ramifications. I do think that is, a huge part now of any project. So I do think people are really trying to do a better job of that. And the question, I suppose, is, even if we can foresee them, what do we do, right? We foresee these problems, but we don't see alternatives. So we're like, okay, we're gonna do it, and we're gonna hope that or we're gonna claim that, or we're gonna genuinely believe that the benefits outweigh the costs, and maybe we're right, or we're going to really put everything on the table. And I'll give another example. In Chicago, it was put on the table. Let's cut off these two basins. Let's just separate them again. Complete, non-starter, just not possible.
Hi.
Okay, one more question in the back there.
I think that Joey's got one.
Oh, sorry.
Hi. I'm a student at the climate school, and we often talk about the power of storytelling and the framing of the narrative, and I see the parallels between building dams to block excess water or to regulate the flow of water, and the same thing with regulating sunlight. And I'm wondering if there are historically strategies that were more effective in terms of opposition to the building of new dams. Also, as time went by and people understood that this makes land less fertile, it is not good for biodiversity, it relocates communities. And if we can learn from these historical strategies.
You mean the idea of just not doing things? Like, okay, let's just not do that big project.
Yeah, like the more effective strategies and the ones that we should avoid when facing a very similar problem now.
Yeah, I mean, I think that's a very good point. I think that I don't think, in terms of dams, to take hydroelectric dams, certainly there are projects that have been stopped, by a lot of organizing against them and people who are being displaced by them. I think that obviously just not doing the damage in the first place makes a whole lot of sense. Most of the issues that I'm talking about here, the die has been cast, as it were. We have crossed that particular bridge, and we don't have a way back. I definitely think that, obviously, approaching every big engineering project or re-engineering project and saying, is this really what we want to do? Makes a lot of sense. But there's, as you know, just huge, often huge amounts of energy and momentum behind these projects. There's tons of money at stake. There's a lot of, so that's very difficult. But I absolutely think that, stopping, not creating these problems would obviously be a lot better than, creating them and having to re-engineer our way out of them. Yeah. Okay.
Thank you so much for Elizabeth. I just wanted to close out with a couple of things. I think one optimistic point it could be that we're here. The climate school is here. A lot of young folks at the climate school are really tackling the problem, and I think we're building a common knowledge and really the base layer for people to start from a much higher position where we started. And I hope this is going to be something that we can provide support to them, and that's why the climate school also one of the goals is. The second good thing is that Elizabeth is going to be outside for the reception, so please join us, those of you who can, and thank you very much for coming.